The law of conservation of energy. Some people call this the fundamental assumption for physicists. It's something we assume to be true no matter what. We assume it so much that we invent potential energy to explain what happens. The universe has a fixed, finite amount of energy, and energy is never created nor destroyed. It's only ever transferred from one place to another and from one type to another. So what we're saying is you can't just create energy, you can't just get rid of it and lose it. What you're actually doing is transferring it from one kind of energy to another, or from one object to another, or whatever. Think about a slippery slide. As you go up the slippery slide, you're using chemical energy in your legs to turn it into, effectively at the top, gravitational potential energy. And then you slide down the slippery slide and you turn that gravitational potential energy into movement energy, kinetic energy. So you didn't invent the energy, you converted it, you didn't create the energy, you converted it from the chemical energy in your legs, and you didn't just create this kinetic energy, you turned gravitational potential energy into kinetic energy. And that's how law of conservation energy works. But the thing is, as you're going down this slippery slide, you hear noise, and the whole slippery slide vibrates, and your bum gets a bit warmer. Actually, the slippery slide gets a bit warmer too, but you usually won't notice it so much because it quickly loses that heat again, transfers that heat again to the air around and things like that. So what you're doing is you're always losing a bit of energy. You're not actually losing it, it's being turned into something else. So all your gravitational potential energy up the top, not all of it gets turned into kinetic energy. And that's another part of this. You can convert energy from potential energy into useful work being you doing something. And in fact, you can turn some work back into energy. We worked to climb up the slippery slide, and that turned it into gravitational energy. But no energy transfer is 100% efficient. There's always some loss. Now that's in quotes. You lose it in that you can no longer have it as useful work energy, but it's not actually destroyed, it's just turning into sound, heat, light. It's going somewhere else. Let me try to give you another illustration. Think about a roller coaster. The roller coaster, the first thing a roller coaster always does is it climbs up a steep hill. We're turning some stored electrical energy into gravitational potential energy. Having got to the top, we don't push or pull it anymore. Everything after this is driven by gravity. So the gravitational potential energy at A gets turned into kinetic energy. At C, you have a maximum of kinetic energy going really fast, actually technically slightly before C, and you have no gravitational potential energy left because you're at the bottom of the hill. But then you go back up into the loop and your kinetic energy gets turned back into gravitational energy. So you slow down again, your kinetic energy drops, but your gravitational potential energy increases. And so on. When you get back to the bottom again, you've gone down to zero potential energy and maximum kinetic energy. But this line is not horizontal because you are always losing some energy. Roller coasters are noisy, they vibrate a lot. You lose energy into heat and sound and a bit of light. You probably won't see a lot of light unless you look closely. That's when you're going around the corners, for example, you might see sparks from the metal on the metal, things like that. You're losing usable energy, but that's how your roller coaster works. If you look closely, you will find the roller coaster never quite gets as high as where it started that first hill climb.